That's right, the long-awaited Chapter 9 test review. Chapter 9 is going to cover your area of polygons like triangles, trapezoids, and parallelograms like you see here. We're also going to work with changes in dimensions and how that affects area and perimeter of the overall new figure. And we're also going to work with missing dimensions, composite figures, and graphing polygons on a coordinate plane. So one little note before we get started, the beginning of the test, you know how the test is normally half things that you've already been quizzed on, 9-1 through 9-3, many of you did extremely well on that quiz. So for those questions, 9-1 through 9-3, I want you to be prepared. The calculations are going to be a little bit harder. So what that means is you need to brush up on dividing by decimals, you need to brush up on your multiplying fractions, things like that. So just a heads up warning on that. Right here we have our first question, which says find the area of the parallelogram. So the area of the parallelogram is going to have a formula base times height. You want to look at the base is 8 and the height up here is 4. Now it's important for this particular formula and this particular problem that the 8 does go in the spot of the B and that the 4 goes in the spot of the H. That the 4 goes in the spot of the H. Now up here at the top, I've also put a little green circle up here, this one, because I want you to realize, the one that I'm erasing right now, I want you to realize that the base could also be up there. So it doesn't have to be on the bottom just because it's the base. So now we're going to substitute and solve. So we get 32 feet squared for the area. That's a pretty straightforward problem. And then we come to this problem. It says, suppose the base and height of the parallelogram, the one we just worked on, is multiplied by 4. What effect would this have on the area of the parallelogram? Explain your reasoning. So this is a very heavily weighted question as far as points go. You're going to have several parts to this question. So the first thing you want to do is write what your original area was, which was 32 feet squared. And then you're going to want to look at the dimensions because they've said that the base and the height are going to be multiplied by 4. So 8 times 4 is 32 and 4 times 4 is 16. So what that means is you have new dimensions now and you want to plug them into your new formula. But before we start that, I want to remind you that immediately you should be thinking about the relationship between changes in dimension and the change to the overall perimeter of the figure. Changes in dimension and the change to the overall area of the figure. Remember, the changes in dimension to the perimeter are a direct change. So, for instance, if we multiplied the dimensions by 5, then the perimeter would be multiplied by 5, and that would be the end of it. But if we multiply the dimensions by 5, and we are talking about the change in the area is multiplied by 5 squared, which is 25. So that's the difference you want to be thinking about. Now we're going to go ahead and plug in our new numbers here, 32 times 16. And as you can see, we're going to get 512 feet squared. So the first piece of your point value is going to be realizing that your original area was 32 feet squared. Your new area is 512 feet squared. Now you want to do the explain portion. So the explain portion goes like this. The area is 4 squared or 16 times greater. It's important that in that first sentence you indicate to me or to whoever is reading your test that you understand that because it's area, we're going to be multiplying it by whatever the dimensions were, which was 4, squared. Because when I say whatever the dimensions are, I mean they told you in the problem the dimensions would be multiplied by 4. That's where we got the 4 to square it. The second piece of your answer says the area of the original figure is 32 feet. So this is where you're going to state the original area, and the area of the new figure, as we found out, is 512 feet squared. And the last one should have been feet squared too. So now that's 3 parts, and this is your fourth part. 512 feet squared divided by 32 feet squared equals 16. So that's your justification and your explanation. All right, so now you're looking at a problem. It says, what is the area of the shaded region in the figure? So the first thing that you want to look at here, hopefully you saw me draw the little piece around it. Let me go ahead and erase that so we can start from that. All right, so as you can see here, what we have is a rectangle, and then we have a triangle cut out of it. It's important that you understand that this is a cutout. So what that means is that you're going to have the dimensions for the rectangle. We're going to do that first. First, we've identified it as a rectangle, and now we're going to label it. All right, so the first thing we did was identify that we're working with a rectangle and a triangle. So now let's draw our rectangle here. You want to draw it in approximately the same size and orientation. Size wasn't the right word, the same orientation. So now we're looking at the dimension of 9 here on the right side, and a 12 here on the bottom. Now this step of drawing your figure and labeling it is the most important one. Remember, this is where many of your errors are going to be made. And if you make an error at this step of the game, everything else is wrong. So as you can see, our triangle has a height of 5 feet, so we're just going to put a 5 here, and it's got a base at the top of also 5. Okay, there we go. I went ahead and rewrote the triangle a little smaller, the actual word, so that you could see the height being 5. Now we're going to go ahead and move down, and we're going to write our formula for each. So the first formula we're going to work with is rectangle. So the formula for an area, the area of a rectangle that we're going to use is area equals length times width. And then while we're here, we can just plug that in. Area equals 12 times 9. Now, because this is a rectangle, the length and width are interchangeable. I'm not looking for a specific position, just that you have the correct numbers there. Now, for the triangle, we've got area equals base times height divided by 2. And then just below that, we're going to plug in. So area equals 5 times 5 divided by 2. So as you can see now at the bottom there, we have that the area of the triangle is also going to be 12.5, and that would be feet squared, but we don't need that just yet. Now we're going to go back to the rectangle and get that 12 times 9. So we've got 12 times 9 gives me 18, so we get 108 right here. So the area here equals 108. Now, the most important part is we need to think now, before we start adding or subtracting, combining or taking away, we need to think about what the figure looks like here. So for the rectangle, it shows us that the rectangle is shaded, and then we need to cut out the triangle because that's not shaded. So that means we're going to subtract. So it's going to be 108 minus 12.5. So as you can see here, we got an area now of 95.5. So before we go ahead and write it up here in our final answer, we're going to think to ourselves, okay, we have area equals 95.5 feet squared, because it is area that we're talking about. Now again, down here, really quickly, just a note, you want to make sure that when you're adding and subtracting decimals that you line them up properly. So in red, that's why I had to add that 0.0 so that I could subtract it properly. Right on this page, you have another cutout figure. It's going to give you the same directions. What are the dimension, or I'm sorry, what is the area of the shaded figure? So that means you have a rectangle and you have a parallelogram being cut out. So let's go ahead and set that up. So as you can see, I went ahead and I have drawn the rectangle, and I've written the word rectangle because you first need to classify or identify the shape, then draw the shape, and then you want to have your formula, area equals length times width. If you're using base times height, that's not terrible either. For right now, for our purposes, that's fine. So now we'll go over here to the other side and we'll start on our parallelogram. So as we can see here, we've got parallelogram, and I've also identified the dimensions. 2 is the height of our parallelogram, and 7 is the base of our parallelogram. So now we can go ahead and write our formula, which is area equals base times height. For this particular problem, it does matter. You do have to have base times height, because remember, parallelogram has nothing to do with the length, because those sides are bent sometimes, or they are actually bent. So the length has nothing to do with it. It's got to be area equals base times height. So now we're just going to substitute and solve. All right, so now you can see, and again, I had to actually adjust this figure a little bit, so obviously the 7 centimeters, well, no, actually it could be about right. Okay, so here's what we did. We went ahead and plugged in the 13 times 7, because we have 13 up there, 7 over there, and then the base and the height of 7 and 2, the base of the parallelogram and the height of the parallelogram. Sorry, that was my alarm. And then we have our total area, which is 91, and then we need to subtract out the parallelogram. So remember, there are going to be some problems where you're going to subtract it, and some problems where you're going to have to add it together. So 91 minus the 14. So here you're going to get 77. So then your final answer is going to be that the area of the shaded figure is going to be area equals 77 centimeters squared. Now notice I don't have the centimeters squared or even the centimeters throughout the whole problem, but at the very end you need to make sure that you have those centimeters squared to indicate that it is an area problem. All right, for this problem it says to find the height of a trapezoid given that it has an area of 1,395 square feet and lengths of its bases are 35 feet and 58 feet. So right away you want to start to go ahead and pick some stuff out. So we need to find the height. We're talking about a trapezoid here. We've got an area of 1,395. Make sure that you know that that's the area. And it says the length of its bases are 35 feet and 58 feet. So all of that right there is going to be important. So now immediately you should think to yourself, okay, this is a missing dimension problem, and this is a height missing dimension problem. So the parallelogram and the triangle and the rectangle and the square, if there was actually one of those, all of those are problems that you would use the original formula and then just solve for the letter that you're solving for. For the area of a trapezoid, when you're working with the missing height and you're trying to find that, there's a related formula. So this is the only one that has a related formula. I know with some of you on the quizzes, you got a little confused about that. So this is the only one with the related formula. So let's go ahead and look and see what that formula is. All right, so as you can see, we're going to start with the related formula, which is height equals 2 times the area divided by base 1 plus base 2. So now we're just going to plug in the information that we have. So now you get 2 times 1395 over 35 plus 58. Because the 35 plus 58 is in parentheses, you want to do that first. So now your new problem is 2 times 1395 divided by 93. So I'm looking at the 93 and the 2 to see if I can cross simplify, and really that's not going to help me out. So I'm just going to have to do it the long way and multiply out the 1395 and the 2. Okay, so as you can see, we got 2,790 divided by 93. And now when I went to go set this up as a division problem, I looked to see how many times I could get 93 into 279. And it occurred to me that 9 times 3 is 27. So let's check that out. And as you can see, 93 times 3 gives us 279. So I got us to that point. And what I did is 279 minus 279 is 0. And then you want to drop the second 0, because this is where most kids are going to make a mistake. It's forgetting about the second 0. So because there's a 0 up here in the right up here, you need to go ahead and add another 0 here. And now you're done. So that's going to be the missing height is going to be 30. And here's what we also need to know. Up here in pink next to the problem is where I'm writing the answer. The height is going to be equal to 30 feet, not 30 feet squared, 30 feet, because remember, we're only talking about one of the dimensions now. We're not talking about the area. All right, moving right along here, we're looking at a problem. It says a rectangle has vertices W, X, Y, and Z, and then they give you the points without graphing. That's very important. All right, so it says without graphing, use the coordinates to find the length of each side, then write the perimeter of the rectangle on the answer line. So here's what's very important about this. First, you need to find the length of each side, and then you need to write the perimeter on the line, which would be the answer line. How you do this, remember in section 9.5, how we used the coordinates without graphing. We lined them up and found the common x's and the common y coordinates, and then found the difference in the other coordinates. So let me show you how we did that. Okay, so as you remember from this section, our first step was going to be to pull out all the points and to line them up and down. The reason we want to do that is so that we can see the differences and the similarities easier. So as you can see, I've started with line WX. The reason I started with line WX is because they share the x coordinate of 16. So right away, remember I had you guys circle the 16 and circle the 16 because that's what they have in common. You can't find the difference in the other coordinate unless one of the coordinates are is the same. So then for this one, we've got 48 minus 24. So that is going to give us a side length of 24. And remember, it doesn't matter which one is on the top or the bottom. You're only finding the difference because you're finding the length of something. You won't have a negative length. You could be at a negative point on the coordinate plane, but you can't have negative length. So now we have the length of one of our sides of the rectangle is 24. So as you can see on the left-hand side, I went ahead and started to draw a triangle. Now this doesn't have to be true to form, obviously. You don't have to have it true to size, but you just want to have it there so that as you find each line, you can, or the length of each line, you can write it on the rectangle. The next one I'm going to select is XY, because if you notice, X and Y both share the Y coordinate 48. So once again, I'm going to go ahead and circle the 48s because you just want to confirm to yourself before you find any differences that you have a similarity in one of the two coordinates. And then I'm going to find the difference between 56 minus 16, and that's going to leave me with a difference of 40. Now, because this is a rectangle, I know that my other two sides are 40 and 24. However, the directions say to find the length of each side. So we can go ahead and do that for Y and Z, and then Z and W. So as you can see here, I went ahead and finished the problem for YZ. You can see that 56 and 56 is the X coordinate that they share. And then the difference between the Y coordinates that are left are you have 48 and 24. And then you find that the difference again is 24. So that matches up on the other side. Now my last one, I'm going to have to squish over here underneath my triangle a little bit. So I want to do that so that you could see everything on one screen. So now for the last one, you want to make sure, because now we're at the end of the row, we just did Y and Z. Well, you don't want to make sure not to forget about Z and W, because you're going to come back around again. Basically, you're going to see the top. So now we're going to have line ZW. And as you can see, they both share the Y coordinate, which is 24. Then you're going to find the difference between 56 and 16. And then you can go ahead and label the bottom piece of your rectangle. Now normally, obviously, that label, the 40, would go on the outside, but I'm kind of squished for space here. So now we have almost finished the problem, and let's go ahead and do this. Right, so what I've done is I took a screenshot, and we're going to go on to the next slide now so that we can do the last piece of the problem. So now that we've finished with the problem, we have each one of the side lengths. The very last piece of the question says, then write the perimeter of the rectangle on the answer line. So now you need to find the perimeter. Remember, don't be confused after all that work. You don't want to make a mistake. So the perimeter is going to be equal to 24 plus 24 plus 40 plus 40, which is what we used for each one of the side lengths. All right, so as you can see here, I went ahead and added those together, and I got that the perimeter is going to be 128 units. So you do want to have units. You want to make sure you understand that this is not units squared, because we're not finding the area, we're only finding the perimeter. All right, so here we have, I believe, a missing dimension problem, but let's double check. It says a triangle has a base of 35 feet and an area of 630 square feet. So the important things we want to pull out is that it's a triangle, that's important, and it has a base of 35 feet. And it has an area of 630 square feet. Now they're also looking for you to find the height. So you want to make sure that you've identified that as well. So remember, as I was discussing with you before, you want to make sure that you realize that trapezoid is really the only one that has a specific formula for finding a missing dimension, like height. So what we're going to use here is just the regular formula for area equals base times height divided by 2, which is going to be the regular formula for area of a triangle. Now I know that 1/2 times base times height is also the formula for area of a triangle, but especially when you're solving for missing dimensions, you want to use the base times height divided by 2. It just makes your life a lot easier. So now we're going to substitute what we know. So we got the 630 from the problem, and because that's the area, we're going to put it in where the A is. We also have a base of 35, so we're going to put that right here. We know we're solving for the height, so that's just going to still remain height. And then we know it's going to all be divided by 2. So now you can start to see why it's helpful that you have the 2 on the bottom instead of the 1/2, because 2 on the bottom now means that you can still solve with the 35 up there. So let's go ahead and multiply each side by 2 so that we can get rid of that divided by 2. So we're going to cross simplify that, and we're left over here with 1260 equals 35h. And now to find the height, you just have to divide 1260 by 35. So as you can see in the top right, I went ahead and multiplied 35 times 4 to get 140, and I realized that was too big. So now we're going to do 35 times 3. I get 15 here, 3 times 3, and then we have 10. So we'll have a 3 here, and that'll give me 105 here. And then you can see that we get 36 here. So then our final answer down here at the bottom is going to be 36 equals h. And so you don't have to flip-flop that around yet, but then, and you don't actually have to flip-flop it around at all, but then when you do write your final answer, you could totally just write it as h equals 36, and now you want to look at your dimensions, and it was feet. Again, one last reminder, remember you're solving for the height, so it's not going to be feet squared, it's just feet. All right, it says the side lengths of a triangle are 5 feet, 10 feet, and 13 feet. Suppose the side lengths are multiplied by 5. Describe the change in the perimeter. Well, remember earlier we were talking about multiplying the dimensions by 5, and then the perimeter would also be multiplied by 5. So that is really the answer to that problem. First, you want to find the original perimeter. Okay, so as you can see, we've done that here. The original perimeter is going to be 28. So now you want to find the new perimeter. All right, so as you can see here, we have the new triangle with the new dimensions, and what I did was I multiplied each of these dimensions by 5. So you can see here, to get from 10 to 50, you multiply it by 5. To get from 13 to 65, you multiply by 5. And to get from 5 to 25, you multiply by 5. So that's what we did. Then we go ahead and write our new perimeter, which is 25 plus 50 plus 65. Then you get a total perimeter of 140. Now here's the part where you're going to have to justify. The way that you're going to justify it is by saying, okay, since the dimensions changed by 5, or were multiplied by 5 rather, then that means the perimeter should be multiplied by 5. So we're going to go ahead and do the multiplication. 28 times 5 is in fact 140. So now we're going to go on to our next page so that we can write down the explanation. All right, so here you can see, let's go ahead and go to that next slide. You can see what we have here. I've taken a screenshot of the old one just so that you can see what we were working on. And we're going to start on the explanation now. And again, just like the one for the area, this has several parts. So it says that the perimeter is 5 times the original perimeter. That's the first part. The perimeter of the original figure is 28 feet. And the perimeter of the new figure is 140 feet. And then our last piece is going to be 140 divided by 28 equals 5. So I've color coded this so that you can see all 4 points. 1, 2, 3, 4. So green, yellow, blue, and white. So this explanation, again, is very heavily weighted. All right, it says Michael's placemat has the dimensions shown below. What is the area of the placemat? So this is another one of those simple, straightforward area problems. You're going to show your original formulas, substitute, and solve. So as you can see here, I started with the formula. Area equals 1/2 times the height times base 1 plus base 2. Then we're going to do area equals 1/2, and we're going to do times 18, because as you can see right here, 18 is our height, times base 1 plus base 2. So we're going to have 22 plus 42. And remember, as usual, those two are going to be interchangeable. So 42, 22, it doesn't matter which order you put those in. What does matter is that you have the 18 outside with the 1/2. All right, so now you have area equals 1/2 times 18 times 64. Now you're going to just go ahead and multiply that out. So you can cross simplify the 2 and the 18 here, just to make your life a little easier. So then your final answer is going to be whatever 9 times 64 is. And as you can see, you get the final answer. Area equals 576 centimeters squared. And remember, you are working with area. It's asking you for the total area, so you want to make sure that you have that on there. All right, so now we're looking at the next problem. It says a scrap of fabric has the dimensions shown. What is the area of the scrap of fabric? Round to the nearest tenth. Now, you want to make sure that you first identify what shape this is, and this is just asking you for the area. So you're just going to plug in and solve. And because this shape is a triangle, we're going to use area equals base times height divided by 2, and feel free to use 1/2 base times height if you would like as well. And again, when we're plugging into a formula, it's very important that we're picking the right dimensions. So for this, we're going to have, oops, I actually just looked at the problem again, and I'm going to go back a little bit here. So let's go back. I usually use base times height divided by 2, but I want you to notice that we've got 18.5 as one of our dimensions. So I'm going to probably use the 1/2 formula now. So let's go ahead and try that. That was actually a really good lesson though. All right, and as I was saying about it being a good lesson, it's because I have many students who ask me, how do you know when to use which formula? Does it matter? It doesn't necessarily matter, but it matters sometimes with regard to it makes it easier. So now let's go ahead and multiply this all out. We can get, so here you can see that I went ahead and multiplied it as fractions. The 2's don't really cross simplify out with anything, so we went ahead and multiplied straight across. We got 555 over 4. So now we're just going to go ahead and do that division. Now you want to remember that you're rounding to the nearest tenth. All right, so now what I've done is I've done the division over here for 555 divided by 4 all the way down to the last part here where I'm dropping my 5. So now I go, okay, how many times can I get 4 into 35? That's going to be 8. And 8 times 4 gives me 32. The reason I stopped here for your benefit, or the reason I started playing again here for your benefit, is because I want to make sure that you understand how far you need to go when you're rounding to the nearest tenth. So 35 minus 2 gives me 3. Now, don't forget that this is where you have to add that decimal. So let me go ahead and add that. I'm going to add that in a different color just so that you know we added it. Decimal, whoops, decimal, decimal, 0, and then we're going to drop that 0 right here. Remember, don't forget to add the decimal in your answer as well. So now we say, okay, how many times does 4 go into 30? Well, I can get 4 into 37 times, so that's good. Then we get 28 down here, and we have 2 left over. Now I need to keep going one more line because we've got 138.7, but depending on what that next number is going to be, that 7 will stay a 7 or it may become an 8. So let's go ahead and see how that works out. We need to add one more 0, drop that way down here. All right, then we see how many times does 4 go into 20. And actually we lucked out because this ends right here because 5 times 4 is 20. Now here's the deal. Your answer, just because it ended perfectly right there, is not 138.75. So far you have area equals 138.75, but remember it said to round to the nearest tenth. The tenth is this column right here. So that means you need to look at this 5 and you need to look and see, okay, the 5 is the indicator for the 7. The 7 either stays a 7 or it goes up to an 8. And remember, this is where you apply your 5 or more, raise the score, 4 or less, let it rest. This is 5 or more, so you want to raise the score, meaning you want to raise that 7 to an 8. So now your final answer here is going to be area equals 138.8. Now we look at our dimensions, inches squared. So this is what I mean when I was talking about making sure to pay attention to precision, because there were a lot of places you could make errors right here, and I want to make sure that you don't make those errors. All right, so this is a composite figure problem here, and it says to find the area of the figure shown below. So the first thing that you need to do is separate this into your shapes. So you want to separate it into the easiest shapes possible. So I've chosen these. Now you want to keep in mind that this part that we're about to do now is the most important part, okay? So you're going to go ahead and figure out what your 2 shapes are going to be, and then you're going to write those. Then you need to label their dimensions. Again, if you make an error in this step right here, the rest of the problem is wrong. So for this long rectangle here, you want to look and see that from here to here, that's my whole side, it's 18. So over here on the figure, I'm going to label it with 18. Then you want to look, okay, from here to here is 6. So I'm going to label that with 6 right up here. So that one was pretty easy. Now let's go ahead and look at our smaller rectangle, okay? Because we can't count that whole side there. So let's go ahead and look. So we do know that this right side right here is going to be 4. So let's go ahead and label that. And now we need to think a little bit, because if we make our bottom dimension for this rectangle 15, it's totally wrong. So what our bottom dimension actually is it's going to be this 15 right here, but we have to subtract something out. Notice our rectangle ends where that pink line is, so we have to subtract out all of that. So you notice up here the 6, that's where we get that from. So we get 15 minus 6 is going to give us 9. So then that means that this area right down here, this whole side length there and the whole side length there, those are 9s. So that means that we're going to label that with a 9. And from here it should be pretty easy. So here we have the area as 108 for our larger rectangle. Now we're going to look on the other side. So now we have area equals 36, and then to find the total area we're just going to combine those. So 108 plus 36, because this is a composite figure that we're not taking away, we're actually sticking 2 things together. So now our total area is going to be 144, and you can't forget the feet squared. And that's because this is an area problem, so you want to make sure it's square feet. On this page, what we've done is use the same figure, because on the test you're going to see a question where it says to find the area, and then it also says to find the perimeter. So for this problem, I went ahead and just whited out the area piece, and I wrote, okay, so now we're finding the perimeter. So for this one, it's also important that you make sure that you have the side lengths labeled correctly. So let's see. We found on our previous page here that this little chunk right here was 9. So let's go ahead and label that as 9. Now we need to figure out, because we're still missing this side right here. So now we need to figure out what that side is going to be. So as you can tell here on the left, see that 18 feet? So that's going to be this side right here, but remember we have to subtract something out. And we're going to subtract out that 4 feet there. So because we know that from here to here is 4 feet. So now let's go ahead and do that. We have 18 minus 4, and that leaves us with 14. So that means that this edge here is 14. So let's just do one quick check run through to make sure we have all of our edges counted. We have this one done, this one, this one, this one, this one, and this one. Perfect. So now we can add them all up. Okay, so now you see that we have the perimeter here is going to be equal to 66 feet, and that's just after we added all of our sides together. All right, so now you can see it says find the base of a parallelogram with a height of 13.5 yards and an area of 159.3 square yards. So now you want to, again, I know at the beginning of the video I said the same thing, but there's only a special formula for finding the height of a trapezoid. So for all of these other ones, you're going to use the basic formula. So let's go ahead and start that now. Area equals base times height. So that's the formula for area of a parallelogram. Then you're going to substitute. So we do know the area. It's 159.3 equals, do we know the base? Find the base. Nope. So we're going to write a B there times the height. We do know the height is 13.5. So now to solve this, this is basically an equation just like we did in chapter 7. So I'll rewrite it so that it looks like an equation that you're used to seeing. All right, so now what you see is 159.3 is equal to 13.5b. So what you need to do here is you need to divide each side by 13.5 because what's being done to the variable, which is b, well, 13.5 is being multiplied by it. So in order to get rid of that, you want to divide by 13.5. So we do that on both sides. All right, so now we get to this spot here where we've got 159.3 divided by 13.5. I'm going to switch to a new screen so that we can do this separately because I did want to make a point to go over this with you. So we have 159.3 divided by, and it was 13.5. Now, I remember I told you in the beginning of this video that the easier problems were just going to be, we're also going to have some decimals and fractions in them, so you wanted to brush up on some stuff. Well, remember, you have to remove the decimal from here, so that now becomes 135, and then you'll also move the decimal out here because you moved one space here, so you need to move one space here. So now your new problem is 1,593 divided by 135. So now you want to do that division. So I've taken us to here where we get 108, we have 11 on the top, and now you have to realize that because we need to continue on, we need to get another decimal. So we have a decimal, and a 0. So then we're going to drop that, and now we get 1,080, and then off to the side I'm just going to do some multiplication and see if I can figure out what that one is. And as you can see here, 135 times 8 gives you 1,080. So that's going to be an 8 right there, and you'll have 1,080 and 0. So your final answer, let's go back to this page, your final answer is going to be that your base is 11.8. So we're going to put 11.8 here. But remember, for your final answer, the one you'll put on the line, it'll look like this, that my base is equal to 11.8 yards. Okay, so now you want to keep in mind, not yards squared, it's just yards because it was a dimension. We are nearing the end. Oh my goodness, only a couple more left and then you will be totally prepared for your test. It says a figure has vertices A, B, C, and D, and then it gives you the points. This is a several part question. So the first part says to graph the figure, then the next part says you need to classify it, and then the last piece says to find the area. So let's go ahead and tackle these one at a time. The first thing that you need to do is graph the points correctly. That will be worth a point. Okay, so as you can see here, I went ahead and graphed these points, so now I'm just going to connect them as best as I can. All right, and so now I can see what type of figure it makes, so that's going to lead me to my next piece, which is to classify it. So I've drawn two lines here on the right because that's what it'll look like on your test. So for the classify part, all you need to do is write trapezoid, and then the last piece is to find the area. So as you can see here, I've used the formula area equals 1/2 times the height times base 1 plus base 2. So now you need to look at the dimensions on the graph and find out how many units each piece is. So if you look here, you see 1, 2, 3. So this base is 3. Then here you're going to also see 1, 2, 3. So the height is 3. And then here you see 1, 2, 3, 4, 5, 6. So the second base is 6. So you want to make sure that you plug those in correctly and then solve for the area. And as you can see here, I went ahead and added everything together, multiplied it. 1/2 of 27 is going to give us the area is equal to 13.5 units squared. So over here on the line, we're going to write area equals 13.5 units squared. All right, so as you can see, I have written that over here on the line. So this is exactly what the problem is going to look like on your test, and these are exactly the same type of answers you need to put on the lines. All right, so as you can see on our last problem, yes, that's right, we have come to our very, very last problem. On the last problem, you will see a composite figure here. Now you want to find the area of the figure. When you're finding the area of the figure, keep in mind that you don't want to count any piece of it twice. So just like we did before, let's go ahead and put a line right there. So now really what we're looking at is we're looking at this figure here, you know, all that space, and we're looking at this figure here, that little space right there. So, and you get that I mean all of the little boxes in there. So let's go ahead. So now what we need to do is count the edges for each of them so that we can come up with our shapes. It looks like we have a square here, so let's go ahead and write square. And then we want to draw our little square. And we've got 1, 2, 1, 2. Yep. So that is in fact a square. So our area is going to be, you can either use length times width or you can use the correct formula, which is s squared. So either way, it's fine. Area equals 2 times 2. So the area of our square here is equal to 4 units. So now let's go ahead and count our rectangle. Our rectangle, we have 1, 2, 3, 4. So we're going to go ahead and label that right there. And then we have 1, 2, 3, 4, 5. Okay, so as you can see, I've labeled that. Then we're going to use our formula, area equals length times width, area equals 4 times 5, and area equals 20. So now, because this is a composite figure, we are going to add those two areas together. So we get 20 plus 4 is going to give us 24, and because it's area, it's going to be units squared. Okay, so that one's just as easy as that. All right, so we finished this question. Now let's go ahead and go on to the next one. Right here, I have written, don't forget, you're going to write everything in the review. The review will be collected. You want to make sure you study, and then study some more. Review dividing decimals and multiplying mixed numbers and fractions. That will definitely help you. And this is just a cute little sneak peek into my world for today. This is what I'm doing today. This is Science Fair, STEM Fair 2015. So I'm sure that you are also on your way or almost finished or totally finished with your STEM Fair. I don't remember if middle school goes first or not. So good luck with your test. You are going to do fabulous, and I look forward to seeing you all in class.